Everyone, welcome to A1 Tutor live class and welcome to the mathematics class. We are still on our topic, which is matrices and determinants. And today we are going to consider matrix part 3, which is the last part of the topic matrix that we'll be considering, which implies that we've taken the first part, which is matrix part 1. We've also taken the second part, which is matrix part 2. In the first type, we're able to define matrix, and also we discussed the basic operations in matrix, that is addition of a matrix, subtraction of a matrix, and multiplication of a matrix. While in the second part of matrix, we discuss the determinant of a square matrix, which is determinant of a 2 by 2 matrix and determinant of a 3 by 3 matrix. We also discuss the inverse of 2 by 2 matrix. So perhaps you had not chance to join the class, the live class. You can do well to watch the part 1 and part 2 of matrix on the YouTube channel. All you need to do is to search for A1 Tutor. Search for A1 Tutor on YouTube, and you are going to have access to all the videos under matrix. Okay, and for our people that are following us on YouTube, if this is the first time you are actually watching our video and this is the first video you are watching, please do well to subscribe, and you'll start having notifications of the videos that will be uploading. Once you subscribe, anytime we upload our videos, you'll be having notifications of our videos, and also have educative content concerning academics. So do well to subscribe, like, and share. So today we are going to round up the matrix as a topic, and today we are basically solving UTME questions. UTME question has to do with matrix. So to recap what we've done in the previous class, we've done the scalar multiplication, where you'll be given a particular matrix, and n here represents scalar, which implies that you will be multiplying everything you have, every of the elements in the matrix by n. And that is why you have NA, NB, NC, ND, NE, and NF. That is, you are multiplying the matrix, all the elements in the matrix. What is an element? An element is each of the values you have in the matrix. So A is an element, B is an element, and C is an element, D is an element, E is an element. So you multiply all of the elements by letter N, and letter N signify the scalar value. Okay, so it can be in this form: 3 matrix, then you have 2, 1, 2, 0. When you multiply this, you have 2 times 2, that is 6. And you multiply 3 times 1, that is 3. 3 times 2, that is 6. And 3 times 0, that is 0. So this will be the what? The scalar multiplication. We also talked about addition of matrices, and we said you can only add a matrix or subtract a matrix when it has the same order. That is, 2 by 2 matrix can be added to another 2 by 2 matrix. 2 or 3 by 3 matrix can also be subtracted from 3 by 3 matrix. So the order of matrices have to be the same. It has to be the same number of column and the same number of row. Okay, the same number of column and the same number of row. When we discussed about multiplication, is that for you to multiply, you need to check a condition first. The condition is that the column of the first matrix should be equal or should be the same with the row of the second matrix. Now, if you are to write the order of this matrix, we are going to have it as row by column, row by column. So what is row? Row is the horizontal representation of your elements, the horizontal. So we have how many rows? We have 1, 2. So this is going to be 2 by we count the colon, which is vertical. The colon is the vertical representation of the elements, which is 1, 2, and 3. So this is 2 by 3. 2 by 3. If you are going to do for this, how many rows is this matrix having? 1, 2, 3. That is 3. How many column? 1, 2. 3 by 2. So if this and this is the same, that means you can multiply. 3 is the same as 3. So it's the same value. That means you can go ahead to multiply. But if it is different, no need of solving anything. The answer will be undefined. Undefined. So the column of the first matrix must be equal or must be the same with the row of the second matrix before you can perform the multiplication of a matrix. So that is the recap of what we did in the previous class. Now let's start with today's class. I said we are going to focus on solving questions that has to do with matrix in UTME. Solving questions that has to do with matrix in UTME. Okay, let's start with the first question. Are we set? Okay, now let's have the first question to solve. The first question we'll be solving. Like I said, we are going to consider UTME questions on matrix. So let's have the first question. The first question that has to do with a UTME question. If we are given if f of x is equals to 3x minus 2i, comma, and p equals to p equals to 2, 1, minus 1, 0, and I is a 2 by 2 identity matrix. A 2 by 2 identity matrix evaluates f of p. Evaluate f of p. So that is what we are asked to do. We are asked to evaluate f of p. Now this question is UTME question 2007. 2007. So we are going to solve this together. Of course, it's very simple. We just need to understand what we are asked to solve. We are given a matrix of P to be this matrix, and we are asked to evaluate function of P, f of P. Now, you check from the beginning of the question, we are given f of x to be this expression. That f of x is equals to 3x minus 2i, where letter I is an identity matrix. Now, if you are asked to find f of p, if I'm asked to find f of p, it means that f of x equals to f of p, meaning that this x has been replaced with what? P. Now it is a function of p, not a function of x. It is a function of p, not a function of x. And that implies that in this expression, anywhere we have x, we change it with what? Letter p. So f of p means that your x now is equated to what? P. In this expression, your x is equated to p. So we are going to have f of p to be equals to 3. This x now we change to p. That's 3p minus 2i minus 2i. So this is what we're actually solving. Now, if f of p equals to 3p minus 3i, 3 in brackets or 3 in matrix, what is p? This is p. This was given as p. So I'm going to replace this with the value of p. That p equals to 2, 1, minus 1, 0. I'll close the brackets, minus, minus. Now what is 2? We have 2 back. But this letter I was given to be an identity matrix of 2 by 2. What is an identity matrix? An identity matrix is a matrix that has its diagonal element to be 1 alone. Example of the identity matrix is 1, 0, 0, 1. So this is a 2 by 2 identity matrix. This is a 2 by 2 identity matrix. And if it is a 3 by 3, 3 by 3 identity matrix is given as 1, 0, 0, 0, 1, 0, 0, 0, 1. Close the brackets, close the matrix. That is 3 by 3. Now, what you observe is that the diagonal is just 1 unit. That is 1. The diagonal of a 3 by 3 also, you see, is only that one that we have as a unit, which is 1. So this is what we call an identity matrix. Identity matrix. A matrix that has its leading diagonal to be 1 and all other elements to be 0. You can see here 1, 1, that's the leading diagonal. Other elements were 0. In 3 by 3 matrix also, we have 1, 1, 1. All other elements was what? 0. So an identity matrix is a matrix that has its leading diagonal to be a unit, which is 1, and other elements to be 0. Other elements to be 0. So if I'm going to represent an identity matrix here, they've told me that it is 2 by 2 already. So that means I'm going to use this. This is a 2 by 2 identity matrix. In matrix form, you have 1, 0, 0, 1, and you close the matrix. Now, this is actually what I explained the other time, scalar multiplication. Scalar multiplication. We have 3 as the scalar value, and we have a matrix beside it. We have 2 as the scalar value, and we have a matrix beside it. So what we are going to do is to open the matrix by using 3 to multiply every element in the matrix. By using 3 to multiply every element in the matrix. And that will lead us to have this as the next solution. The next solution, that is, the next step will be multiplying each of these elements in the matrix by the scalar value. Permit me to clean this side so we can have this place to finish up the solution. So we're going to have f of p, still solving f of p. That was the question. F of p equals to, now let's go, 3 times 2. That is what? 6. The 3 again times 1. That is what? 3. Now let's multiply the remaining one. This 3 multiplied by minus 1, that is minus 3. The 3 again multiplied by 0, that is 0. So we can close the brackets, minus the other side. We are going to be using this also to multiply the bracket. 2 multiplied by 1, that will give us 2. And 2 multiplied by 0, that will give us 0. The same 2 multiplied by 0 here, that will give us 0. And 2 again multiplied by 1, that will give us 2. Then we have the brackets or the matrix form closed. Now we can go ahead to subtract because the operation the basic operation in between the two matrices is minus. So I need to subtract this matrix from the other matrix. That is subtraction of what? Matrix. You can find that in the first part of matrix that we did, and it's on YouTube. You can check the YouTube and check basic operation on matrix. That is matrix part 1. It's on YouTube. You can do well to watch the video for details, understanding. So let's go ahead to subtract. F of P will be equals to corresponding values is what you are subtracting. Corresponding value. This is corresponding to this value. At least they have the same arrangement, the same position, the same position is what you are going to be subtracting. So 6 and 2 have the same position. So to subtract, you are going to have 6 minus 2. Then the next one is this and this. That is 3 and 0. That will give us 3 minus 0. Next, we have minus 3 and 0. Minus 3 minus 0. Then we have 0 minus 2. 0 minus 2. Close the matrix. F of P equals to, by normal subtraction, you are taking away 2 from 6. That will give you 4. You are taking away 0 from 3. That will give you 3. You are taking away 0 from minus 3. That is still minus 3. And you are taking away 2 from 0. That will be minus 2. So the final answer is 4, 3, minus 3, minus 2. 4, 3, minus 3, minus 2. That will be the final answer of this question, of this UTME question. I believe this is clear to us. If yes, please, let's kindly signify. So we move on to the next question. If this solution is clear to us, please kindly signify. Okay, Olamide Kabolaji, thanks for your response. Do we have any response again? We are proceeding to the next UTME question. We are proceeding to the next UTME question. I need your reactions based on this question that was solved. And if you are watching our videos online, please, if you have a question, do well to drop your question in the comment section. We will definitely give you a response. Do well to drop your question in the comment section. Okay, that means we can proceed to the next question. We can proceed to the next question, the next UTME question. The next UTME question, let's wipe the board. If you have not written down this, you can do well to probably take a screenshot so we can wipe the board and move on to the next. If yes, please, thumbs up. If I can wipe the board, thumbs up. So we move on to the next class, to the next question. Okay, let's go on to have the next question solved. We are still on solving UTME questions. Solving UTME questions. Solving UTME questions. All right, so let's take another question based on the UTME. Another question. Now we are going to take a question on inverse or determinant of a matrix. We take a question on inverse, then we take another question on determinant of a matrix. Determinant of a matrix. Okay, so let's consider this question. If the question is UTME 2014, if the matrix given as minus x and 12 minus 1 4 and we have equals to minus 12, comma, find x. Find the value of x. So we are given this question to find the value of x. This implies that the determinant of this matrix is given to be this value. Okay, the determinant of this matrix, this is the way the sign was done. The determinant of this matrix is given to be what? Minus 12. And we are asked to find the value of x. Take note that to get the determinants of a 2 by 2 matrix, what you do is to take the difference of the product of the major diagonal, this is major diagonal, minus the minor diagonal, and this is the minor diagonal. What I mean by that is that determinant will be equals to AD minus BC. That is, I'm multiplying D times A, that is AD. I'm multiplying C times B, that is BC. Then I'll take the difference. That will give me the what? The determinant of the matrix, that is 2 by 2 matrix. Now, this is also a 2 by 2 matrix. I'm going to multiply this. That is the step. Minus x times 4 minus, then we take the minor diagonal, that is minus 1 times 12. Everything should be equals to this answer, that is minus 12. They've given us the answer already. That the answer, which is the determinant of this matrix, will give us minus 12. So we are to equate it to minus 12 so we can get a value of what? X. So we go ahead to solve this. That minus x times 4 will give us minus 4x minus, which is the natural minus we have here. This natural minus is the minus I'm having here, is the minus I'm having here. Now, minus 1 multiplied by 12, that should give us minus 12. All should be equals to minus 12. Minus 4x minus multiply minus, that will give me plus 12, which is equals to minus 12. By collection of like times, if plus 12 moves to the other side and cross the equal sign, we are going to be having minus 4x is equals to minus 12, which is this minus 12. Then plus 12 also we change to minus 12. So we have minus 12. Minus 4x will now be equals to minus 12 minus 12. Minus 12 minus 12 is minus 24. To get the value of x, you need to divide both sides by the coefficient of x, which is minus 4. Divide both sides by minus 4. That is the coefficient of what? X. So we are going to have minus 4x is divided by minus 4, which is equals to minus 24 divided by minus 4. If minus cancel minus out, minus cancel minus, 4 cancel out 4, minus cancel minus, we have x is left, and x is equals to 24 over 4. By dividing this, the answer should be 6. 24 divided by 4 is 6. So the value of x is 6. The value of x is 6. I believe this is clear to us. If this solving is clear to us, please kindly signify. We are moving on to the next question. The value of x is 6. All right. So thank you for your response, Olamilekan Abolaji. So we can go on to take the next question, right? If that's the case, please take down this. You can pen it down, write it inside your notes, or probably you take a screenshot. We are moving on to solve another UTME question on matrix. UTME question on matrix. If I'm good to go by wiping up the board, please let me know by giving a reaction, thumbs up. If I'm good to go Can I wipe the board now? Okay. Now let's proceed with the next question. This is the second question that we solved under matrix. Now we are taking the third question under matrix. The third question under matrix. The third question under matrix. Still solving UTME questions. We are still solving UTME questions. Now let's have another question, another UTME question. Okay, let's consider a question that has to do with the inverse of a matrix 2 by 2, the inverse of a matrix 2 by 2, the inverse of a matrix 2 by 2. We have 2017, okay, 2010 question says that if P is equals to 2 minus 3, 1, 1, close the brackets, comma, what is P raised to power minus 1, question mark. P raised to power minus 1 means what is the inverse of matrix A? What is the inverse of matrix A? That is the question. So when you see raised to power minus 1 in matrix, it means inverse of a matrix. It means inverse of a matrix. So what we are asked to do is to find the inverse of a matrix. Let's go ahead to solve that together. Solution to that question. We have the matrix itself to be 2 minus 3, 1, 1. And we are asked to find the inverse of this matrix. The first step is to interchange or swap. Let's call it interchanging or swapping the major diagonal, swapping this and this. So that means you are going to exchange the arrangement. 2 will go to the place of 1, 1 will go to the place of 2. That's swapping. You are going to swap that. So if you swap, you are going to have something of this nature, 1, 2. After you've done that, that's the first step, swapping the what? The major diagonal, the major diagonal. After you've done that, you are going to change the sign of the minor diagonal. Take note, I said this is called major diagonal. So this is called the minor diagonal. All right. So the next thing I need to do is to change the sign of the minor diagonal element. And this is minor diagonal, and this also is minor diagonal. Change the sign. That means if the sign was positive before, you are going to have negative. If the sign was negative, you are going to have positive. That is the meaning of changing the sign of the minor diagonal. Changing the sign of the minor diagonal. Changing the sign of 1, I'm going to have minus 1 because it was positive 1 before. Now I've changed the sign. It is now minus 1, which is negative 1. Changing the sign of minus 3, that will be plus 3. And you can close the matrix now. So that is the first step. The second step, this is the first step. The second step is to find the determinant of this matrix. Find the determinant of this matrix. That is the original matrix given to you in the question. Let's go ahead to do that. Determinant of this matrix. Solving determinants. Determinants. 2 minus 3, 1, 1. How do you get the determinants? Very simple. It is the multiplication of the major element of the major diagonal, that is 2 times 1, close bracket, the natural minus in between the formula of a determinant, open another bracket, then 1 times minus 3. 1 times minus 3. That will give us 2 times 1 is 2. We have the natural minus there. 1 times minus 3, that will give us minus 3. And we are going to simplify this by using the minus to open the brackets. 2. Minus times minus is plus. Minus times minus is plus. That means we have plus 3. Adding the 2 together, the answer is 5. So this is step 2. What I've done now is what? Step 2. Step 2. Now we are going to step 3. What is step 3? P inverse will now be equals to step 1 result divided by step 2 result. Step 1 divided by step 2. So what is step 1? This is what we got for step 1. This matrix form. We got the matrix. We got 1 plus 3, or let me say 3 plus 3 minus 1, 2, divided by step 2. What did you get in step 2? We got 5. That is what? 5. Step 2, we got what? 5. So all you need to do now is to divide each of the elements by the denominator, or by the denominator, which is what? 5. And you'll be having 1 divided by 5. 1 divided by 5, that is 1 over 5, plus 3, which is also 3. 3 divided by 5, 3 divided by 5, minus 1 divided by 5, minus 1 divided by 5, 2 divided by 5, 2 divided by 5, and this is the final answer. The final answer. So this is the way we solve the inverse of a 2 by 2 matrix. This is the way we solve the inverse of a 2 by 2 matrix. If this is clear to you, please kindly signify, and let's proceed to the next question. Okay, Olamilekan, thank you for your response. All right, so let's move on to question number 4 on UTME. Question number 4 on UTME. Before that, let's take a pause and address our followers, our fans on YouTube. Now, this is an amazing moment to learn from A1 Tutor, and that is why we brought it to you, to your convenience, by always uploading our live session classes to YouTube. So in case you are not chance to join the classes, wherever you are in the whole world, you can do well to have access to our videos on YouTube. To make it very easy and an easy task for you, not to be searching for our videos all the time on YouTube, all you need to do is to click the subscribe button. You know, once you click the subscribe buttons, you will be receiving notifications of our videos. You'll be receiving notifications of our education content, educative content that we have on our YouTube page. Subscribe the button, click on the subscribe button, click on the notification bell, and also any of our video that you watch, do well to drop your comments in the comment section. It's very important. If you have questions, you have suggestions, you have some review, you have some criticism, do well to drop it in the comment section. We would like to have a feedback from you after you've watched our videos. We really, really appreciate that. So do well to always drop a comment in the comment section. And also, for the sake of other people to learn and to benefit from this, you can share our link on your social medias. You can share our link and also give it a like. The more they like, the more people will want to watch our videos. Thank you so much. Let's go on to the next question. That will be the last question we'll be taking for today on solving questions under UTME based on the topic matrices and determinants. So we go on to solve number 4 question. The next question that we are going to solve now. Let's have the next question. So we have still solving UTME question. UTME question. We have the next question. That will be question number 4. And we are going to take a question that will be a bit technical, so we can all solve it together. The question that will be a bit technical for us, so we can all solve it together. All right. So we have a question, UTME 2010. Given that, okay, evaluate, the question was evaluate, a matrix was given 2, 0, 5, 4, 6, 3, 8, 9, 1. So when you see kind of questions like this in UTME, what you're asked to do is to find the determinant. Because when we're discussing in part 2 matrix, we said determinant can be symbolized by the following: determinant of A, determinant of A, or determinant of A. All these symbol means determinant of a matrix, determinant of a matrix, determinant of a matrix. So you can see that the second one here was used. This symbol here was used to represent this. So we have to find the determinant of a matrix already given to us here. So if I'm going to find this, I'm asked to find the determinant of that matrix. And how will I do that? We are going to do that together. First thing to do is to first give the sign to your matrix. Plus, minus, plus. You always give it to the first row of the matrix, the first row of the matrix. Now, what do we do next? You have to pick this and the sign together and say plus 2. Open another matrix. You have to cancel wherever 2, this particular 2, where is connected to. We have here, cancel this, and write the remaining one. The remaining one you have is this value here. So you'll be writing inside the matrix 6, 3, 9, 1. Then you can close back the matrix. You do the same thing for the second one. The second one is minus 0, minus 0. So if I select minus 0 like this, I'm going to write minus 0, have the matrix of it also. Now I'm going to cancel wherever minus 0 is appearing. So let me use another color for that. Minus 0 is here, so it's going to cancel out all this row, and it's going to cancel out this column also. So what you are going to have left is this and this. So that will be 4, 3, 8, 1. 4, 3, 8, 1. Then the next one is to make use of the next one, which is plus 5. If I take plus 5 now, I'll write plus 5, draw the matrix. Then I'm going to cancel where 5 is actually connecting to. It has the first row, 5 is in the first row and is in the third column. So I'm going to cancel the first row and the third column, the first row and the third column. So to do that, we have this is cancelled out and the third column also is cancelled out. I'll be having left this value, which is 4, 6, 8, 9. 4, 6, 8, 9. So we are good to go now. We are good to go by multiplying the matrix now. Plus 2, this is going to be a 2 by 2 determinant. That is 1 times 6, that is 6, minus 9 times 3, that is 27, close the bracket, minus 0 in brackets, 4 times 1, that is 4, and 8 times 3, that is minus 24. This is a 2 by 2 matrix that I'm solving here, the determinant of a 2 by 2. Here you're going to have plus 5 in brackets, 9 times 4, that is 36, minus 8 times 6, which is 42. 8 times 6, which is what? 42. So we're going to simplify it to get 48, sorry. 8 times 2 should be 48. 8 times 6 is 48. We are going to have 2 in bracket. Subtract 27 from 6. That is minus 21. Then this is 0. So when you multiply this, the whole of this bracket by 0, your answer will be 0. So we have plus. Let's move to the next bracket. That is plus 5 in bracket. Subtracting 48 from 36. 48 from 36. We are going to have minus 12. Minus 12. Multiply 2 by 21. Minus 21. That is minus 42. Then 5 multiply 12, that is minus 60. So minus 42, minus 42, minus 60, that is going to give us minus 102. Minus 102. So the determinant of this matrix is minus 102. Minus 102. I believe this is clear to us. If yes, kindly signify. If the determinants that we solved now, the determinant of a 3 by 3 matrix, if it is clear to us, please signify. We are rounding up the class already. All right. I believe this is clear to us. So I have a question for us, our followers on YouTube. I want you to solve this question and drop your answer in the comment section on YouTube. Drop your answer in the comment section. Evaluate this matrix. 1, 2, 0, 4 minus 3, 2, 3, 1, minus 1. So what you are asked to find is to find the determinant of the matrix. You are asked to find the determinant of this given matrix. So evaluate this question, solve this question, and drop your response in the comment section. Drop your answer in the comments section on YouTube. Drop your answer in the comment section. So thank you for your time today. We've been able to solve questions that has to do with matrices. We're able to touch questions that have to do with basic operation. That was the first question. And the number 2 question was basically on the determinant of a 2 by 2 matrix, while question 3 was basically on basic operation also, and question 4 was on determinant of a 3 by 3 matrix. Question 3, we did inverse of 2 by 2 matrix. So we've been able to touch all the aspects that we discussed in this topic. First question has to do with basic operation in matrix. Second question has to do with determinant of 2 by 2 matrix. The third question has to do with inverse of a 2 by 2 matrix. And the fourth question is the determinant of 3 by 3 matrix. So thank you for your time. Do not forget that we have another class that will be starting soon. In few minutes time, English class will be coming up. Stay online and stay connected to join the class. Thank you for your time. See you in few minutes time. See you in few minutes time.